One of the questions that's often asked when it comes to radians and degrees is the length of an arc. And so we want to know what's the distance of this arc. Now, to find that, we say it's easy. You just need to go your degrees, or your angle, but not really your angle, times your radius. Because your angle is measured now in radians. So we need to go your radians times your radius. So it always needs to be in radians, and then you have your radius, which is r. And then you just multiply them. And that will tell you the distance of this arc. So it says determine the length of the arc, find the distance of this arc, that subtends each angle at the center of the circle of radius 5. So, I mean, there's a bunch of words right there that aren't entirely necessary for us to understand what we're after, which is just we're finding the length of an arc has a radius of 5 centimeters. And we've got 5 questions to do it, and it's giving us different measurements here. So A is our arc length, is going to be theta times r. Now theta is 2 in this case, and our radius was, I believe, 5 centimeters. Yeah. So in the end, we're going to get an answer of 10 centimeters. I mean, that's really, really straightforward. There's not much going on here. So you got your radians times your radius. Now my radians is 4 over 5, and my radius is just 5. So then I get 20 over 5, which reduces just to 4 centimeters. So I have 4 centimeters as my arc length. Now continuing on, I've got theta r. The theta in this case is going to be 1/2 times pi. So I'm going to write it as 1. The numerator is 1, and the pi is also the numerator. So 1 times pi is pi, and then just a 2 is on the denominator. So that is my radians, and then my radius was 5. So my answer is going to be 5 times pi, which is 5 pi, over 2 centimeters. I don't know what that actually is, what that distance is. I mean, I know pi is like 3. 5 times 3 is 15. 15 divided by 2 is like 7.5. So it's something slightly above 7.5, but I don't actually know. Turns out it's approximately, if you had a calculator, you could do it, but it's around 7.9 centimeters. Now, more often, you're going to get something there where it's in degrees. So first thing we need to do is we need to take our theta here, this is the word theta, and you want to convert it to radians. So I need to get rid of degrees. If I'm getting rid of degrees, I put degrees on the bottom with 180 and put the pi up top. So I get my degree symbols can cancel, which is what I want. I don't want degrees. So I have 45 pi over 180. And we've done this one before. Both of these can be divided by 45. So it reduces to pi, and 180 divided by 45 is 4. So therefore, if you're going to find your arc length, it's going to be theta r. Theta is pi over 4, so that's how many radians, times your radius, which is 5. And I purposely wrote that kind of smaller up above to keep the numerators together and the denominators kind of lined up. So I get 5 pi over 4, apparently don't know what 4 is, centimeters. And again, 5 times 3 is 15, and then 15 divided by 4 is, I don't know, like 3 point something. So I want you to leave your answer like this, but in case you were actually just wondering, what is that roughly? Well, it's roughly 3.9 centimeters. That's how long this thing is. So that required a little bit more work, because I had to convert my degrees into radians. And that's the same thing here. I got degrees, so I need to convert this thing. So I've got 120 degrees, and so I want to get rid of the degrees. I put that on the bottom with 180 and pi. So I have 120 pi over 180, because the pi's cancel out. I don't need to, the degrees cancel out. I don't need to write them. Now these can be divided by 60. So that gets you 2 pi over 3. So if I'm going to find my arc length, therefore my arc length is going to be theta r, where theta in this case is 2 pi over 3 and my radius is 5. Yeah, just making sure. So I have 2 times 5 is 10, and there's a pi over 3 centimeters. So that's the exact answer. Now, 10 times 3, pi is roughly 3, it's 30. 30 divided by 3 is 10. So you're looking at something above 10 if you want to know exactly what it was. It's actually approximately 10.5 centimeters. But I don't care too much about the approximations, though it is helpful to understand how long this is. Without guessing or estimating, I wouldn't really know how long that is. Okay, so that'll be it for, there's only 2 more questions? Yeah, there's only 2 more questions. We'll do those as well. And then we can move on to something that is completely different again. So let's take a look here. Determine the angle. So that means if you have A equals theta r, determine the angle is there. And they want our answer in degrees and in radians. So, it tells you that the radius is 4. And it says that determine the angle. And each arc length. So this is my radius, I got that, and my arc length is below. So I'll start by writing A equals theta r, or r theta, doesn't really matter. And this is already given. A is 3, theta we don't know, and the radius it said was 4. So we'll divide this by 4. So we've got theta equals 3 over 4. And this, remember, is in radians. So maybe we can write that down just to remember. We don't write the radian symbol, but it's just helpful to keep track of what we're looking at here. Now, it wants us to convert. It wants us to go to degrees. So if I want degrees, I'll put it up top with the 180. Put the pi on the bottom. So I have a 3 times 180, and then I have a 4 pi on the bottom with the degree symbol. Now, the 3 times 18 is 54, and there's the extra 0. So 54, so 540 over 4 pi. That can be reduced. 540 can be divided by 4. It can be cut in half to be 270, and cut that in half. It would be 135. So this is going to be 135 over pi degrees. So there's my answer. I had theta in my radians, and I have theta in degrees. Now, in B here, it's saying that my arc length is 5.5, so I'll write that, and theta, and my radius, I've forgotten, is 4. So it's times 4. So I'll divide by 4, divide by 4. So theta equals 5.5 over 4. By the way, if you don't want decimals, you can always double. Like 5.5 doubled is 11, and 4 doubled is 8. So that's one way of figuring out how to get a fraction without the decimals there. So that's what my radians is, but I want it in degrees as well. So I'll put degrees on the top, put 180. And pi on the bottom. Great, now I gotta do 11 times 180. So you can put that off to the side here. 0, 8, 1. And then 0, 8, 1. So it's 0, 8, 9, 1. So 1980. So 1980 over 8 pi degrees. And I can cut that in half. Cut in half, so that would be 990 over 4 pi degrees. I just cut the top in half. And I can actually do that again and get 495. Yeah, 495 over 2 pi degrees. And I can't cut that. That's divisible by 5, but not by 2. So that is my answer in radians. Sorry, in degrees. So, I mean, getting radians was super easy. Just divide by 4. I doubled it to get 11 over 8. But then later on, actually, that doubling was kind of nice because then when I multiplied here, I didn't have to worry about decimals anymore. I never thought of that. And then I could just get into degrees by going 180 over pi. So that's that. We're done with this now. We can move on to something completely different.